On this quite lovely morning, we have looked at a lot of things. It's quite packed. We looked at polynomials, we looked at other functions, we looked at a lot of stuff. Now I only have one more question for you for the day. Sir, what is exactly the difference between x-intercepts and zeros?
Excellent question.
Begin with the very first question, which is to understand differences between zeros and x-intercepts, right? Now, let me explain like this, that zeros could be imaginary or real. Now, the real zeros are actually treated as x-intercepts. So these real zeros are actually treated as x-intercepts. So I hope that clearly says everything about zeros and x-intercepts. Well, there's something more to it, and that is related with behavior of the graph or behavior of graph near x-intercepts. Now this is very important concept. The zeros also provide us with some additional information, right? So let's look into zeros' capability of providing us with some additional information. What kind of information does zeros provide, which is missing from x-intercepts? Well, let me take three different scenarios to explain this, and I'll also tell you what x-intercept is, right, and then what zero is. Now, if I draw a graph something like this, let's say something like this. Now in this graph, what do you notice? Well, clearly what we see here, there are a couple of x-intercepts. So these are the x-intercepts, right? Wherever the graph crosses the x-axis, those are the x-intercepts. Okay, sorry, y, right? So the x-intercepts are these three, right? Wherever graph crosses or touches. Now, these are also zeros, but zeros have an hidden information which you could read that comes from the order of zero, and sometimes we say multiplicity. That is how many zeros are there at that x-intercept. So what is this multiplicity? That really tells us how many zeros at x-intercept. That is the order or multiplicity, right? Now, this kind of a curve which goes like a straight line, let me show you again. The kind of a curve which goes like a straight line, now here we will say the order is 1. Yeah, so the order is 1 for 0. It goes like a straight line, right? So it's like a linear curve, right? Now if I have something like this, kind of like this, it bounces back. Do you see that? So here we have two zeros. We say multiplicity is 2, right? Now it behaves like a quadratic function, just terms. If it is x to the power of 4, there will be 4 zeros, or we can say 2 or even. We can say even in general. Even number of zeros, right? In general, multiple of 2. However, if you have something like this on a graph, right, that signifies You guessed what, right? So odd number of zeros. So the multiplicity could be 3, 5, 7, 9, whatever. Higher the number of zeros, flatter it should be when you sketch a graph. Perfect. So I hope you get the concept. So clearly, zeros could be imaginary or real. Real zeros also represent x-intercepts, but they have additional information, that is, depending on the order or multiplicity of the zero, you know the behavior of the function near the x-intercept. If you have 1 0, order is 1, it behaves like a linear function. If you have even number of zeros, it behaves like a parabola, right? Turning, right? The turning point. And if you have odd number of zeros, then it goes like this. It decides to turn but moves on. So it is not a turning point. We call this shape as a tilde. So it goes like this, right? Now, so with that, I hope it's clear what is the difference between zeros and x-intercepts. Nurmeen, can you summarize what you learned about zeros and x-intercepts?
So it's quite fascinating because people use it interchangeably, and some of my friends, they treat it as if it is the same concept, but it's not, right? So basically, x-intercept is always real, and it's basically when the graph intersects your x-axis, so it makes sense. And zeros could be real or imaginary.
Perfect.
So let's say that, and also zeros would determine the behavior of the graph. So let's say that the graph is intersecting the x-axis, so we call the x-intercept. There could be more than 1 0 on there.
Yes.
Right? So like let's say if it's, it could be, depending on the zeros you have, it would determine whether your graph would go in a circular, take a turn, whether it's like cubic or linear. Right? So if it's about 1, then you cut a straight line. Yes. If it's 2, you have a nice curve, which is why we have that quadratic sort of look. Yes. And if it's 3, it's like cubic. It doesn't know where to go, so it just turns.
So you really summarized it very well. Now let's do an example.
Sure.
Okay. So let me give you a polynomial in factored form.
Okay.
Let the polynomial be f of x equals to x plus 2 to the power of 3, which is cubic factor, times x squared times x minus 1.
Okay.
How will you graph this polynomial?
Okay, so we just have to take different pieces.
Yeah.
So we have our x-intercepts right in front of us. That would be -2, 0, and +1.
Perfect.
Right? And the degree would be 6.
How?
3 plus 2 plus 1.
That is it. So it's even degree function.
Right. You also look at your multiplicity. Or the order. Right? So we would start, because both, so it's even, so both would be up.
Both will be up. Right side up because the leading coefficient is also positive. Right side up because it is even, both up.
Both up.
Right. Now let's sketch.
So let's say that you first start on -2, correct?
Yeah.
So from there, remember our degree was 3.
Yeah.
So that means we go from the second quadrant.
So here you are in second quadrant. Come down here. Yeah.
Third. So you have a curve.
Yeah. Cubic term.
Cubic term.
Yeah.
And then the second point was 0.
Yeah.
So we have a curve.
Yeah.
On there.
So it turns at the origin.
But you wouldn't cross the origin.
Yeah.
Because it would only turn and come back.
X squared is the factor.
Right.
That makes sense, right? Yeah.
And then the last one is easy because it's linear.
Yeah.
It was x.
X minus 1 will be 0 at x equals to 1.
Right.
So it's linear at
that.
Yeah.
So you end up both up.
Perfect. So let me just summarize it for you. Again, our reference frame is this, right? Here's the origin. So x plus 2 whole cube means we have a 0 here, right? And this 0 has multiplicity of 3, so the curve coming will go down like a cubic function.
Correct.
Perfect.
Yeah.
And here we have x squared, right?
Yeah.
We have x squared. So it turns back and then goes here. So it goes from here, comes down, turns, and then goes.
Right.
Is it correct?
Yes.
So it goes from here, cubic turn, parabolic, up like a line.
Linear.
Wow!
Great, right?
That's good. That's good.